In today's video, we will explore one of the most elegant concepts in distributed systems, the distributed hash table or DHT. If you have ever wondered how Cassandra, DynamoDB, or even BitTorrent distribute massive amounts of data across hundreds of nodes seamlessly, this video will make that concept crystal clear. By the end, you will understand what a DHT is, how consistent hashing works, and how Cassandra uses it to scale effortlessly. Hi there, welcome to Tech and Career Bytes. I'm a software professional with over 2 decades of experience, including 7 years in leadership roles at a global product based organization. Let's start with a simple question. When you store data across multiple servers, how do you decide which machine stores which key? For example, say you have 4 database nodes A, B, C, and D, and you hash user IDs to distribute the keys. Seems simple, right? But there is a huge problem. The moment you add or remove a node, the number n changes, and that means almost all your keys have to be remapped. You end up reshuffling tons of data, which is slow and inefficient. That is where distributed hash tables come in. They solve this exact problem. A distributed hash table or DHT is like a hash map spread across a cluster of machines. Instead of keeping everything in one table, it uses consistent hashing to decide which node owns which keys. Here is the trick. Imagine all possible hash values arranged in a circle, or what we call a hash ring. Each node is assigned a point on this ring. When you hash a key, it lands somewhere on the ring, and the next node clockwise from that position becomes responsible for storing that key. Now, when a node joins or leaves, only a small part of the ring changes, not the entire data set. That is what makes the DHTs so powerful for scalability. Think of the hash ring as a clock. Node A covers from 12 to 4 o'clock. Node B covers 4 to 8 o'clock. Node C covers 8 to 12 o'clock. If the hash of user 123 lands at 5 o'clock, it belongs to node B. Now, suppose you add node D. It just takes a slice of the ring, and only a small number of keys move. The rest remain untouched. That's consistent hashing in action. Now, let's connect this to Apache Cassandra, one of the most widely used distributed databases in the world. Cassandra does not have a master node. Every node is equal and participates in a peer-to-peer ring based on DHT principles. Here is how Cassandra uses it. Every row in Cassandra has a partition key. Cassandra hashes that key using the Murmur tree algorithm. That hash value determines which token range the key belongs to and which node is responsible for that range. Each physical node is divided into many small token ranges, usually 256 per node. These are called virtual nodes, and they help balance the load evenly. Data is not just stored once. It is replicated to the next few nodes clockwise to ensure high availability. So, Cassandra's DHT ensures data is balanced, fault tolerant, and scales smoothly as nodes join or leave. Now, let's look at a tiny Java example that mimics how a DHT works, including virtual nodes, just like Cassandra. Each physical node is represented by multiple virtual nodes. This makes data distribution smoother and more balanced. This function converts each key into a number, its position on the ring. Once we have the key's hash, we assign that key to the next node clockwise. If you want to explore the complete code, I have added it to my GitHub. The link is in the video description below. Now, visualize this hashing in motion. As new nodes join, small portions of data shift. When a node fails, its token ranges are taken over by others. The load stays evenly distributed. This mechanism makes Cassandra both highly available and horizontal scalable. No single point of failure and no painful rebalancing. Let's quickly recap what we have learned. DHT maps keys to nodes deterministically. Consistent hashing minimizes data movement during scaling. Virtual nodes improve balance and recovery. Cassandra uses DHT to assign token ranges and replicas. In short, a DHT is like a self-balancing, self-scaling directive for your data. It is the silent backbone that makes distributed databases like Cassandra, DynamoDB, and others work reliably at scale. If you found this video helpful, give us a thumbs up and subscribe to our channel for more interesting tech topics. Do check out our other videos on software performance optimization case studies, coding, system design, big data, and career growth. My name is Rupa, and I thank you so much for watching this video. See you next time.